The National Electrical Code, or NEC, is a comprehensive set of standards designed to ensure electrical safety in buildings and other structures. It's a critical resource for electricians, engineers, inspectors, and anyone involved in electrical work. The NEC is updated regularly to reflect new technologies, materials, and safety practices. These updates are vital for maintaining the highest level of electrical safety. The proposals for changes to the NEC are carefully considered by the NEC committee. This committee is composed of experts from various fields including electrical contractors, engineers, manufacturers, and safety inspectors. The goal of these proposals is to improve the NEC and make it more effective in protecting people and property from electrical hazards. When examining NEC proposals, it's essential to understand the different sections of the code and how they relate to specific electrical installations. For instance, Article 210 covers branch circuits, which are the circuits that supply power to outlets, lighting, and appliances. Article 220 deals with calculating the electrical load requirements for a building. Article 250 covers grounding and bonding, which are critical for preventing electrical shock and fire hazards. Understanding these sections is fundamental to interpreting and evaluating the proposed changes. The proposals often address a wide range of issues. These can include changes to wiring methods, equipment specifications, installation requirements, and safety procedures. Some proposals might aim to clarify existing code language to prevent misinterpretations. Others might introduce new requirements to address emerging safety concerns. For example, there might be proposals related to the installation of electric vehicle charging stations or the use of new types of electrical equipment. Each proposal is typically accompanied by a justification explaining the need for the change and the potential benefits it would bring. This justification is crucial for understanding the rationale behind the proposal and evaluating its merits. When reviewing a proposal, it's important to consider its potential impact on different stakeholders. This includes electricians, contractors, building owners, and manufacturers. Some changes might increase the cost of electrical installations, while others might improve safety or reduce maintenance requirements. A careful analysis of the costs and benefits is essential. The NEC is adopted and enforced by various jurisdictions, including states, cities, and counties. These jurisdictions may adopt the NEC as is, or they may make amendments to it to suit their local needs. It's crucial to be aware of the specific electrical codes that are in effect in your area. This information is typically available from local building departments or electrical inspection agencies. The NEMA website is a valuable resource for accessing NEC proposals and other information related to electrical standards. NEMA, the National Electrical Manufacturers Association, is an organization that represents manufacturers of electrical equipment and medical imaging devices. NEMA plays an active role in the development of electrical standards and codes, including the NEC. The NEMA website provides access to a wide range of information, including technical standards, industry news, and educational resources. It's a valuable resource for anyone involved in the electrical industry. When reviewing NEC proposals on the NEMA website, it's important to pay attention to the proposal number and the section of the NEC that it addresses. This will help you quickly identify the relevant information and understand the context of the proposal. The website also typically provides a summary of the proposal and a justification for the proposed change. This information can help you quickly assess the key aspects of the proposal. In addition to reviewing the proposals themselves, it's also helpful to read the comments and feedback submitted by other stakeholders. This can provide valuable insights into the potential impacts of the proposed changes and help you form your own opinion on the merits of the proposal. The NEC is organized into chapters, articles, and sections. Each of these divisions covers a specific topic or aspect of electrical installations. Understanding the structure of the NEC is essential for navigating the code and finding the information you need. Chapter 1 of the NEC covers general requirements such as definitions, rules of interpretation, and administrative provisions. Chapter 2 covers wiring and protection, including requirements for conductors, overcurrent protection, and grounding. Chapter 3 covers wiring methods and materials, including requirements for different types of cables, conduits, and raceways. Chapter 4 covers equipment for general use, including requirements for receptacles, switches, lighting fixtures, and appliances. Chapter 5 covers special occupancies such as hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment such as electric signs, elevators, and welders. Chapter 7 covers special conditions such as emergency systems, fire alarm systems, and critical operations power systems. Chapter 8 covers communications systems such as telephone, data, and cable television systems. Chapter 9 contains tables and examples that are used to calculate electrical loads and conductor sizes. When working with the NEC, it's important to consult the latest edition of the code. The NEC is typically updated every 3 years, and each edition incorporates the latest changes and revisions. Using an outdated version of the code can lead to non-compliance and potential safety hazards. The NEC contains many tables that are used to determine conductor ampacity, conduit fill, and other important electrical parameters. These tables are based on extensive testing and engineering analysis. It's crucial to use these tables correctly to ensure that electrical installations are safe and compliant. For example, Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to 600 volts. This table is used to determine the maximum current that a conductor can safely carry under various conditions. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. It's important to select the correct conductor size to prevent overheating and potential fire hazards. The NEC also contains requirements for overcurrent protection, such as fuses and circuit breakers. Overcurrent protection devices are designed to protect electrical circuits from excessive current that could cause damage or fire. The size of the overcurrent protection device must be properly matched to the ampacity of the conductors it protects. It's important to follow the NEC requirements for overcurrent protection to ensure the safety of electrical installation. Grounding and bonding are essential for preventing electrical shock and fire hazards. Grounding provides a lower impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device. Bonding connects all metal parts of an electrical system together to create a common ground potential. This helps to prevent voltage differences that could cause electrical shock. The NEC contains detailed requirements for grounding and bonding. It's important to follow these requirements carefully to ensure the safety of electrical installations. The NEC also addresses the installation of specific types of electrical equipment such as lighting fixtures, receptacles, and appliances. These requirements are designed to ensure that the equipment is installed safely and correctly. For example, the NEC contains requirements for the location and spacing of receptacles in dwelling units. These requirements are intended to provide convenient access to electrical power and to prevent the use of extension cords, which can be a safety hazard. The NEC also addresses the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Electrical equipment used in hazardous locations must be specially designed and installed to prevent ignition of the flammable materials. The NEC classifies hazardous locations into different classes and divisions depending on the type and concentration of the flammable materials. It's important to select the correct type of electrical equipment for the specific hazardous location. The NEC also contains requirements for emergency systems such as backup generators and uninterruptible power supplies, or UPSs. Emergency systems are designed to provide power to essential loads during a power outage. These loads may include lighting, fire alarm systems, and critical equipment. The NEC specifies the requirements for the design, installation, and testing of emergency systems. It's important to follow these requirements to ensure that emergency systems are reliable and effective. The NEC is a complex and comprehensive document. It's important to have a thorough understanding of the code to ensure that electrical installations are safe and compliant. The NEMA website is a valuable resource for accessing NEC proposals and other information related to electrical standards. By staying informed about the latest changes and revisions to the NEC, you can help to protect people and property from electrical hazards. Remember to always consult with a qualified electrician or electrical engineer for any electrical work. They have the knowledge and experience to ensure that electrical installations are safe and compliant with the NEC. Moreover, it's beneficial to attend training courses and seminars in the NEC to stay up to date on the latest requirements and best practices. These courses can provide valuable insights into the code and help you to apply it effectively in your work. In conclusion, understanding the NEC proposals on the NEMA website is crucial for anyone involved in the electrical industry. By staying informed about these proposals and their potential impacts, you can contribute to the development of safer and more effective electrical standards. Always prioritize safety and compliance when working with electricity, and consult with qualified professionals when needed.